Good morning, class. At this point, we're looking at functions and relations. Or what's this topic? Functions. Alright, the relationship between two variables. We spoke about the domain and the range. Then we spoke about sketching graphs. No? And then I think we started with the parabolas. No? The quadratic graph. Let me just check there. You did 7.3. So your homework was exercise 7.4. Any problems here? Any problems? Number 1. Number 2? Yes. Who said yes? Nobody. Number 3? Yes. Problem. Okay, let's go to number 3. So it says study the sketch graphs for each line segment. Write down the domain of the graph. People, what is domain? All possible x values. Okay, so let's look at A first. Number 1. The domain. Where does this graph? Remember, we always read domain from left to right. Increasing and decreasing from left to right. So we're going from left to right on your x-axis. Where does this graph exist at negative infinity? No. How can it exist here if it's stopping there? What's wrong with you? So does this graph exist at negative infinity? No. Where does it start existing at? An x value of negative 4. Up until x is equal to 1. So the domain is x is greater than or equal to negative 4, but less than or equal to 1. Can you see that, people? Is that both closed circles? Huh? Yes, so it's going to be equal as well. If it's an open circle, then it will be just more than or less than. Okay. Yes, that's number 1. Number 2, write down the range of the graph. What is range? All possible y values. So does this graph exist at negative infinity? No. Where does it start existing at? Negative 1 till 4. So the range is y is greater than or equal to negative 1, but less than equal to 4. Okay. Calculate the equation of the line segment. So the equation, how to calculate the equation, it must be in the form of y equals mx plus c. Not so? So how do you calculate m? It's going to be y2 minus y1 over x2 minus x1. So if this is going to be x1, y1, then of course x2, y2. So we're going to have negative 1 minus 4 over negative 4 minus 1, which is negative 5 and negative 5, which is 1. Doesn't make sense. Is this gradient not positive? Yes. So what do we see now? Y equals 1x plus c. To calculate c, I substitute one of the points lying on this graph. So you substitute 1 and 4. That's an x and a y. So 4 is equal to 1 plus c. C is equal to 3. Y is equal to x plus 3. Any issues there? Any problems with B? B is the same now as this one, eh? It's just going the other way around. So you guys okay with that? Let's look at C. Same story. But here's an open circle here. Let's look at the domain here. The domain and the range. So the domain is all possible x values. So what's my x value here? Negative 3, and it goes till 0. Can you see that? So we say x is greater than negative 3 but less than 0. Is it equal at negative 3? Yes. Is it equal at 0? No. You see it's an open circle here. It's not equal there. You see that people? The range is all possible. Y values. Does this graph exist at negative infinity? No. We start existing where? Negative 3 until 6. So y is greater than negative 3 but less than 6. Can it be a closed circle at negative 3? And is it a closed circle at negative 3? No. Open. So do I put the equal sign here? No. Do I put the equal sign at 6? Yes. Why? Because that's a closed circle at 6. And I'm sure you can do that there. The domain for this graph here, the graph we're reading from left to right. This graph starts existing at negative 1 till 3. So x is greater than negative 4 but less than 3. Is it equal at negative 4? Yes. Is it equal at 3? No. What's my range? Y is equal to negative 1. Do you see that? Let's look here. There's a K here. So, the main range. So, what's my domain? X is greater than negative 4. But they said 2. Range is y values. Y is greater than negative 1, but less than. Okay. Why am I not putting equal signs? So it's open circles. Okay. I think they made a mistake there. They wanted to put a number in there. But whatever the number would have been your K value here. Not so. The next one, the domain here in the range. Domain is all possible x values. The only x value that exists here is 2. What's my range? It's going from negative 1 to 8. So y is greater than negative 1 but less than 8. Can be equal at negative 1? No. Can be equal at 8? Yes. Closer. Okay. Then we went on to 7.5. We drew the parabola. We spoke about this here. Not so? Yes. Alright. And I gave you these 3 sums to draw. Right. So let's look at this quickly. So you had to draw a table. Not so? Okay. Let's just take this off here. Let's get this Mickey Mouse here. Copy. Paste. Okay. So when you substituted negative 2, you got 8 out, not so? From your table, negative 2 gave you 8. Not so? 1 gives you 2. Am I right? Negative 1 and 2. 0 and 0. 1 and 2. 2 and 8. Okay, and you guys must got more points in this. No? From the turning point, we draw. Okay. And there we go. Okay. Now let's go to the. Look at the next graph. The next graph look like that. Not so? That was 1 and negative 1. You had 2 and negative 4. You got 1 and negative 1 and negative 1. It was in line with that, no? Negative 2 and negative 4. Okay. You all okay with this, no? Yes, you know how to do this thing. And the last one, we'll talk about this now today. Negative 2 was 0, not so? Negative 1 was negative 3, 1 was 3, not so? Did you guys do the homework? Now why you make it sound as if I don't know what I'm talking about? You must say, yes, yes, yes. Alright, that's what your graph should do. Not so? So let's look at the interpretation of the graphs. Okay? Interpreting the graphs. If we talk about interpretation, is basically telling us we must read from the graphs and stuff like that. Okay? So we're going to have a list of things that we're going to interpret from these graphs. And we're going to do it for all these graphs. Okay? So the first thing is, we're going to look at the domain of these three graphs. Yes? Your graph don't look like it? No. How your graph look like? Upside down? No. Don't be upside down. Maybe your mind is upside down. I'm joking. Right, so from the table, so you got x and y, not so? 0 corresponded with what? Negative 4. But if you look here, this is minus 1, minus 2, minus 3, minus 4. But you're saying it's on top here. You saying your graph looks like that. But this is the positive part of your y. And this is always negative at the bottom. Does it make sense? Yes or no?
Yes.
So why is your graph looking like this?
At the bottom.
Does it look so?
No, it starts from the 0.
Like this? But if you put 0 in here, so y is equal to 0 squared minus 4. So 0 minus 4, which is minus 4. No? Now put 2 in. What do you get? Well, what did 2 give you on your table here? Sorry? Well, put 2 in here. Put it on your calculator, let's see. Give it a chance. The 0. Now put negative 3 in, what do you get? So you might have done a mistake in your calculation. Okay, everybody else on the same page? No. So as we said, we're going to do a couple of questions pertaining to these graphs. So the first question is, you start here. You all have drawn this graph, not so? Right. Start here. What is the domain of this graph? Page this graph quickly. What is your domain and your range? Right, write down your domain and your range of these graphs. Right. So look at them, what's the domain of this graph? It goes negative infinity, positive infinity. Not so. So what do we say? X is an element of all real numbers. Not so. The range. Does this graph exist at negative infinity? No. Where does it start existing at? 0 onwards. So y is greater than 0. Can be equal to 0? Yes. Why? So the graph exists there. Not so? Right. Now the same question I want you guys to answer for this graph quickly. Same question. Domain and range. Domain and range. Right, so what's the domain here? Negative infinity, positive infinity, not so? X is an element of all real numbers. What's the range? Does this graph exist at negative infinity? Yes, that's why the arrows are here. Negative infinity, yes. Where does it stop existing at? 0. So in other words, y must be less than and equal to 0. Let's do the domain and the range of this graph. Didn't I give you 3 for more? Oh, that's the 1, 2, right. Same thing, domain and range. Domain, all possible x values. Range is all possible y values. Okay, so what is the domain? X an element of all real numbers. What's the range? Does this graph exist at negative infinity? No. Where does it start existing at? Negative 4 onwards. So we got y and negative 4. But it must be going up, so it must be more than, yes, more than negative 4. Can it be equal as well? Yes, more than and equal to negative. Are you all okay with this? Anybody that's confused? No. Let's go back. Let's see where the graph is increasing. Where is this graph an increasing function? Where is the graph decreasing? Now, when we're reading the increasing and decreasing part of the graph, increasing and decreasing, then we always read from left to right. So make a note there. When we're reading our increasing or decreasing function, we always read from left to right. Yes? Sorry? Whenever reading increasing or decreasing, we read from left to right. Right, so when we look at where the graph is increasing, where the graph is increasing, we read from left to right. So as x increases, that's the thing you must consider. As x increases, what happens to the graph? Now think about it. Moving from left to right, it is where x is increasing, in other words. Not so. So as x increases, from negative infinity, what happens to this graph? Getting smaller, not so. So what happens to the graph? It is decreasing. Where is it decreasing? For x is less than 0. Does it make sense? Let's go again. It doesn't look like it's sticking, no? Let's try again. What's the note we said? When reading increasing and decreasing, we'll read from left to right. Now we're moving from left to right. What do you notice? This is the furthest left part of the graph. Negative infinity. What do you notice? From left to right, the graph is decreasing. So the graph is decreasing where? It's decreasing for x is less than 0. What happens on the other side? Increasing. That's not what I'm looking at now. No? We look at one at a time. So, the graph is decreasing for x is less than 0. At 0 is neither increasing nor decreasing. You guys understand? Let's see what happens here on this side of the graph. What's happening? The graph is increasing. So where is the graph increasing? For x is more than 0. Nice. You guys understand? Right. So x is more than 0. Right. Now answer that increasing, decreasing question there. What is this here? Take that Mickey Mouse off. Answer. Right. Guys ready? Increasing, decreasing. Okay. So where we read it from left to right. What happens here? Graph is increasing. Where is the graph increasing? For x is less than 0. This part here, the graph is decreasing. Where is it decreasing? X is more than 0. You all okay with that? Alright? Whoa, whoa, whoa. Wat gaan aan met ons vandaag? Right. Do that one. Increasing or decreasing? So, increasing, decreasing. So this part of the graph, it is decreasing. Not so. It's decreasing for which values of x? X is less than 0. You will agree with that? It's decreasing for x is less than 0 and it's increasing for x is more than 0. Will you guys understand? Any confusion? Go back. Now we need to look at the coordinates of the turning point. Okay? Coordinates of the turning point, so we're looking at turning point. You all agree this is a turning point here. Now does that turning point have a maximum value or a minimum value? Is the turning point happening at the maximum or its minimum on the graph? It is at its minimum. Not so? So the coordinates of the turning point is 0 and 0. Not so? So secondly, we're talking about the maximum and minimum. The graph has a minimum value of, what is minimum value, smallest value? 0. And occurs at x equals 0. You see that, people? There's a minimum value of 0 and occurs at x equal to 0. You all understand? So write that down and you answer it for the next two graphs. Okay, so this graph here, yes, has a turning point, its coordinate of 0 and 0, not so. What else did we say? Maximum or minimum? The turning point happens where? On top, so it's a maximum. The turning point is at the maximum, not so. So this graph will have a maximum value of, the maximum value, this biggest value is 0, and occurs, let's double see, at x is equal to 0. Okay, that doesn't sound like it's sticking much, so let's look at this example. The turning point here is 0 and 4. What can we say about this? The graph will have a, if it does this, the turning point is at a minimum. If it does that, the turning point is at a maximum. So here, this graph will have a minimum value of 4. And it occurs at an x value of 0. If it does this, it turns at 0 and minus 20. That means to say this graph will have a maximum value of negative 20. And it occurs at an x value of 0. Not that difficult. Not so? Take this off. Whoops. And I'll give you a minute to do that one. A couple of seconds, sorry, not a minute. Don't have a minute to spare. So what can we say here? The turning point occurs where? Turning point? 0 and? Negative 4. This graph will have a minimum value of negative 4 and occurs at x equals 0. Will you all understand? Let's go big. Okay. Now we're going to look at something exciting. Okay. Oh, yes. Okay. Now we're going to look at more than and less than. With regards to more than and less than a certain value. Just take this off here. So I hope you guys don't have any separation issues. You're not taking this off. No. So if this was f of x was equal to that function. Okay, that was f of x. So it will be f of x for now. No? F of x and the last one was also f of x. My question is, where's f of x equal to 0? That's number 1. Where's f of x greater than 0? And where's f of x less than and equal to 0? Okay. Firstly, where's f of x equal to 0? Where f of x is greater than 0? And where f of x is less than and equal to 0? Okay. So, f of x is what to us? F of x is the same as a 1. So in other words, the function 2x squared is equal to 0 where? So we see where y is actually equal to 0. Can you see this x-axis? What is the equation of this x-axis? Y is equal to 0. Can you see that, people? What did you say? What is the equation of the x-axis? What did you say? Oh my word! mx plus c. Julle is te oulik, man. Oh no. Okay. People, this x-axis. The equation of the x-axis is y is equal to. What's the equation of the y-axis? Huh? Yes, if this one is y is equal to 0. You know, of course that one's going to be x equal to 0. Okay. So, where's the function? Where's the graph? F of x is the graph, not so. Where's the graph equal to 0? The graph is equal to 0 where? That's the only part where the graph is 0. Not so? So what do I say? X is equal to 0. Not so? Let's look at it again. Where's the graph? F of x equal to 0. It's equal to 0 and x equal to 0. That's the only point where it's 0. You would agree with that? No. Let's look at the other part. Where's the function greater than 0. So if you look at this graph, I'm going to take all of this off now. I don't want the graph to be too messy. Okay. You see, if something is greater than 0, it must be positive. Not so. Something less than 0, it must be negative. You all okay with that? So looking here, f of x is greater than 0, that means to say f of x must be positive. Okay. So is this part of the graph greater than 0? Huh? Listen, this is 8. 8. 2. 2. How can it not be greater than 0? Not O. So 8. Confusing yourselves here. Let's go again. For f of x is more than 0, it is where f of x is positive, or the graph is positive. Is this graph part positive here? Yes, it must be more than 0. No? It's positive, positive, positive. Positive, yes? But here. Would I include 0 there? Why not? It says greater than. It doesn't say equal to. Only greater than. So, it's excluding that and including this here. Not so. Now there's two ways I can write that. I can say x is an element of all the real numbers, provided x is not equal to 0. That's one way I can write it. Not so. Or I can say, or we can say x is less than 0 or x is more than 0. That is also acceptable. You guys understand? Bit confusing, na? Initially. Say bit by. Bit by. Confusing. Well, you guys got it? No. Okay, nice. Not everybody's going to understand this. No? But we'll try and make most of you understand. Okay. Now, next one. Where is f of x less than or equal to 0? Where is f of x less than or equal to 0? Is there any part of the graph that is less than 0? No. Where? Show me. Where? Nowhere. No part of this graph of f is under this line. There's no part of this graph that is negative. Has a negative y value. Okay. So my question is there any part of the graph that's negative? No. But remember there's an equal sign as well. Is there any part of the graph where f of x is equal to 0? Yes. Where? At 0. So the only part here is x is equal to 0. Now did you get it? And let's see if you got it. Try that now on this Mickey Mouse here. Let's see if you understood what's happening. Where is f of x equal to 0? Where is f of x greater than 0? Where is f of x less than x? Right. Who would like to give the first answer? F of x equal to 0 where? Okay, before I forget, no? Normally they would ask you for which values of x. I forgot to tell you that part. No? The most important part. So you're thinking, why am I using x's only? No? Yes, that should have read. I wrote 4 wrong twice. What's wrong with me? I know how you guys feel. For which values of values of x will semicolon f of x equal to 0, f of x be greater than 0, or f of x less than or equal to 0. Okay, you guys got it? For which value or values of x will. That's how it's normally asked, okay? So, for which values of x is f of x equal to 0? Sorry? X is equal to 0. Nice. Where is f of x greater than 0? Is it any part of this graph that's greater than 0? You're right. There's no part that is positive. So what do I write? I write no solution. There's no solution on this graph that is greater than 0. No part of the graph. So no solution. Where is f of x less than 0? Which is negative. All of this here and all of that there. Not so. But it's equal to 0 as well. So I will include that. So what do you notice now? It's the whole graph. Not so. The whole tutti frutti. Right. So what do I write now? If it's everything, if it includes everything, what do I write? X, yes. Is an element, yes. A yes. And here you think there's something wrong with you guys, no? X is an element of real number. Which means to say all the values of x satisfy that condition. Right, you guys got it? Right, let's put your tray, your thought in your intelligence to test here now. Okay. Where is f of x equal to 0? This is now if that is f of x. No? Is f of x equal to 0? Is f of x less than 0? Is f of x more than the other way around? Huh? Is f of x more than 0? In the exam they ask you one of it, they don't ask you all three. Increasing and decreasing the same, they don't ask you all of them. I'm just showing you how to do the different methods, okay? Right. So is f of x equal to 0? It means to say it lies on this line. So it's at? This means where x is equal to 0, f of x. So x is equal to negative 2 or x equal to 2. Not so. Where is f of x greater than 0? So it means to say where it's above this line. Not so. So where is it above the line? There and there. Can you see that? So in other words, x has to be less than minus 2 or x must be more than 2. You see that, people? Where is f of x less than or equal to 0 is this part of the graph here. This must where it is negative. Not so. So what am I now saying? It is from negative 2 till 2. So x is greater than negative 2 but less than 2. Can it be equal at negative 2? Yes. And at 2? Yes. Okay. People, I want you guys to do, the one more thing is, they would ask you to write down the equation of the axis of symmetry. Okay? Got your axis? The axis of symmetry. That is like a mirror image. We spoke about the symmetrical line already, no? So x here is equal to 0. You see this y-axis? Your symmetrical line. Not so. In all three cases, x is equal to 0 there. For homework, I want you guys, using the table, to draw the following graphs. The first graph I want you to draw is y is equal to x squared. Just see which graph you drew already. Minus 4. So you're going to draw for me x squared minus 1. The second graph, y is equal to minus x squared plus 1. The third graph, y is equal to x squared plus 1. Y is equal to x squared minus x squared minus 1. Then you draw for me the graph y is equal to 2x squared plus 18. Sorry, minus 2x squared plus 18. Y is equal to minus 2x squared plus 1. Y is equal to... That's too much? Sorry, man. I get it carried away here. Right. For all 6 graphs, you're going to draw in table. That's number 1. Then you answer all those questions as we did, which was domain, range, increasing, decreasing, turning point, listing maximum, minimum, axis of symmetry, greater than, less than, equal. Okay, yes. Did I write down where? Number 4, this is minus x squared minus 1. Where did I write that? No. Listen, this is x squared minus 1. Minus x squared plus 1. X squared plus 1 and minus x squared. Whoops. Minus x squared minus 1. Okay. You need to take a photo. It's all what we did. No? When I was listening again, domain, range, increasing, decreasing, turning point, maximum, minimum, axis of symmetry, that means f of x equal to 0, f of x less than equal to 0, f of x more than 0. It's exactly what we did. Why do you need to write it down? Right, you guys know what to do. And enjoy the weekend.